Okay. Hello. You camp on this profile. Okay, well, welcome to your campsite. Very glad to have you. Okay, guys, those who are joining in for the first time, hello. You are at the right place at the very right time, because we are basically going to be looking at hello. Good day to you, or let's say good evening, good everything that's at night. Okay, guys, we are actually going to look now. We are going to step into the world of simplification and the simplification, basically algebraic expressions, because we have actually been doing GEC questions. I was live during the course of today, so if you guys want to check out the 2 sessions that I've had, actually 3 now, I have 3 live sessions that you can actually watch on my YouTube page. The link is in the bio, guys. If you're going to check out the YouTube channel, please check out the link in the bio. It's MATHSISAGAME. Yes, guys, grade 9 tomorrow morning as usual at 5 a.m. we'll be having a session. So we are just wanting now to sort of like continue where we left off, and where we had left off last, or let me say during today, we had finished answering this question 27, all right, which was basically a simplification question, all right. And just as a way of recapping, how did we answer that question for those that may have probably missed it? The question says simplify. So what we simply did is we looked at the numerator, we looked at the denominator, and we simplified what's in the numerator. How? You can see, first and foremost, we need to establish how many terms we have in the numerator. And we did say earlier on that what separates terms in an expression is plus and minus, all right? Currently, Ruben, I cannot be about geometry. If you want to check out geometry, please do go to my YouTube channel, and the link is in my bio. I have done geometry type questions, even GEC type questions on geometry. You're more than welcome to go and spend some time and go and camp there for a little while. The link is in my bio. Just go and check it out. The playlist is there, all right, and you can actually spend some time there. Also, I have done sessions before this one, where we have looked at exponential type questions, simplification of exponents, SIMA. So you can actually go and check that out too. We are now entering into the world of expressions, and yes, some questions do involve exponents, so just be mindful of that as we go through the questions, that you actually are mindful of what we do. Okay, so we simplified the numerator, as I said, guys, by first looking at how many terms we have. So this is term 1, then obviously the minus sign separates this term from this one. We did establish that brackets will combine terms, multiplication combines terms, division combines terms, but addition and subtraction will separate terms. So for instance, 3y into this bracket, this is one single term here, okay? Then this plus sign will separate this term from this one, okay? All right, so that's basically okay, sorry about that. So as I said, guys, that here, in the top, there are definitely 1, 2, 3 terms. So then what we do is we simplify the numerator. How? 15y to the power 3 is a single term, so we write it there. And then what we do is we say minus 3y and we multiply minus 3y into negative y and multiply minus 3y into positive 2. How? By distributing negative 3y into the brackets for 2 terms using what? Multiplication of s, multiplication of the signs, then followed by n, multiplication of the numbers, followed by l, multiplication of the letters. So negative times the negative is positive. 3 times, there's a 1 here that you cannot see, is 3, and then y times y is y squared. Then you do the same thing with the second term. Negative times the positive is negative. 3 times 2 is 6. Then y obviously gets attached to the negative 6. And obviously this term is plus 6y squared. It's a standalone term all over 3y. In the numerator, when you look at it again, you can see there are like terms. The like terms that we have here are 3y squared and plus 6y squared. So what you then do is you add the like terms. 15y cubed is still a standalone term. 3y squared plus 6y squared gives you 9y squared, because when you add like terms, you keep the variable and its exponent, you add the coefficients. So positive 3 plus 6 gives you 9. Then you have negative 6y as your last term. This is all over what? 3y. Now, when you have established that you have 3 terms in the numerator and in the denominator you have 1, if it is possible to factorize the numerator, you factorize it, especially if factorization will lead to a simplification in the denominator. So in the denominator, we have 3y. So when we factorize, we first ask ourselves, how many terms do we now have in the numerator? We still have 1, 2, 3 terms. Then we ask, to factorize, do we have a highest common factor, a HCF? We call that a highest common, the SNL in the movies, the ones that you shouldn't watch, but the sign, number, letter that you need to take out so that you can factorize this 3-term expression. So we can clearly see that our highest common factor sign for these 3 terms, the first term, its sign is usually the highest common factor sign. So it's a positive number, positive sign. The highest common factor number between 15,9 and negative 6 is positive 3. And then lastly, the highest common factor letter between y squared, y cubed, y squared, and y is obviously the common base variable that has the lowest exponent. When we factorize, we take out the common variable base for the letters that has the lowest exponent, and that is, ladies and gentlemen, the letter y. Not y squared or y to the power 3, but y. So when we take out y as well with the 3, that is positive. That means that is our highest common factor. So this here, guys, is our highest common factor. Mimi Milan, stop sending the same message over and over again. I've seen the message. I see what you said. I have a live session in the mornings at 5 a.m. So that's basically, if you want a session again tomorrow, you will have to make it a point that you join the live session at 5 a.m. tomorrow morning. Or obviously, if it's later on in the day, that's if I am able to do one. You'll have to just check when I do go live. Hopefully you followed, and basically you'll get a notification when I'm live. So if you take out the 3y, what is left behind when you take out the 3y? 3 times what gives you 15? It's positive 5. Then y times what gives you y cubed? It is y squared. So when you take out the highest common factor, you write here inside the bracket what is left over. Okay, so for the first term, it's 5y squared. For the second term, if you take out a 3y, 3 times what gives you a positive 9? It is positive 3. Then y times what gives you y squared? Obviously, it's another y that you have there. And then if you take out the 3y, 3 times what gives you negative 6? It's definitely negative 2. What about the letter? If you took out a y and you need a y at the end, do you need to add another y? No, you don't. So basically, that's how you take out the highest common factor for an expression in the numerator. Now, what do you have left now in the numerator? You have 3y outside the bracket, and outside we have 5y squared plus 3y minus 2. Sina says, so we take the y that has the lowest exponent. Yes, as I said, for a common base ladder, you take out the base, the common base that has the lowest exponent when you take out a highest common factor. Are you with me? Sima, how do you take out a negative sign? If the first term in your expression, when you are factorizing, it has a negative sign, you take out a negative sign. That's one of the ways that you take out a negative sign. Or when you are applying the sign change rule. Okay, so you always check your first term. Is your first term positive? You take out a positive sign. If your first term was negative, you take out a negative sign. Then you would have to check the signs that are inside. If you take out a negative, obviously all the signs inside your bracket are going to change. But since you took out a positive here, you can see that this sign did not change, that sign did not change. But had we taken out a negative, these signs inside the bracket would have definitely changed. Okay. Now that you've taken out the highest common factor in the numerator, and now you have the expression inside the bracket, 3y and 3y can cancel. Why? I explained earlier on today that we can only cancel something at the top and at the bottom if the cancellation happens and it is not across an addition and a subtraction sign. We only cancel if cancellation does not happen across an addition and a subtraction sign. So this 3y, guys, right, is outside the bracket. Its relationship, 3y with the bracket, the relationship with 3y and the bracket is multiply. Okay, let's get rid of this guy, whoever it is. Cox, goodbye. Okay, so it's very important, guys. 3y can cancel here, but look at this. If we had an expression and it was 3y plus 5 over 5, we would not cancel here. Never. Why? Because we do not cancel common things if it's across an addition and a subtraction sign. The thing is, if you look at 3y plus 5, these are two terms. So we cannot cancel this 3y and this 3y because it is across an addition or a subtraction sign. We dare not cancel here. We cannot cancel here. But here, we can definitely cancel. Okay? Because this 3y is outside the bracket. It's multiplied with this bracket. So therefore, this 3y and this 3y, you can definitely cancel. Okay? Also, Mastole was asking, why did we put a bracket? Look, we are factorizing, Mastole. Whenever you do factorization and you take out a highest common factor because you have a highest common factor, you first take out that highest common factor by identifying it first. That the highest common factor according to the sign is a positive, the highest common factor according to the number 15, 9, and 16, and 6 is 3, and then the highest common factor letter between y cubed, y squared, and y is y. So therefore your highest common factor is 3y. What is left over? Then you write down those things that are left over inside the brackets. That's why we put brackets, because it is to simplify. Then we get that answer, which is 5y squared plus 3y minus 2. And basically that answer, it is our option. Option who? Option D. 5y squared plus 3y minus 2. Okay. Seen, like I said, you cannot cancel across an addition and a subtraction sign. Different story, seen, if let's say it was 3y plus 5 over 3y plus 5. Okay. Obviously, 3y plus 5 over 3y plus 5. These are the same things. So this divided by that, right? It would be an important thing for you to just note that this here, these two can be cancelled because this divided by that is actually equal to what? It's equal to 1, okay? But what is important here, we can never cancel another term, but it is across a addition and a subtraction sign. It cannot happen, okay? We cannot do that. So let's just be careful about that because that's very important. Guys, let's move on. This is still grade 9, all right? We're moving on to the next question. So the first question, which is basically the new question for today, is this one. Yeah, cool. So let's look at this, okay? Simplify the square root of y to the power 8 plus 9 over 16y to the power 8. So when we look at this, what do we have here? We have a square root. Then what do we have inside the square root? We have y to the power 8 plus 9 over 16y to the power 8. How many terms do we have inside the square root? We have 1 plus sign 2. These two terms, what are they? These two terms, we can clearly see that this first term has a y to the power 8. This second term also has a variable which has an exponent which is 8. So we call these two terms what? Yes, super not angel. We call these like terms. So if these are like terms, that means we can add these like terms. So let's do this and rewrite this for our own interest. Okay, now listen to me and listen to me well. We must first add what we have here that is inside the square root. Okay, remember, you cannot apply the square root to this term and apply the square root to that term, because you will remember when I explained earlier on with the live lesson I did in the morning that the square root of a times b leads to a splitting. You can separate the bases by taking the square root of each if there's a multiplication sign. Also, if there is a division sign between two bases, you can separate and split the square root. But the minute, guys, we have an addition or a subtraction sign, we cannot do this. Separate. We cannot separate these. No. This is absolute nonsense. We don't do it for addition and subtraction of bases inside the bracket. So what I'm trying to say here is that you cannot split this, all right, to y to the power 8, the square root, under the square root, plus this separately. We can't do it because the law does not allow us to. Okay, the law of surds doesn't allow us to. So what we do is we add the like terms. Okay, when we add like terms, what did we say, guys? We keep the variable and its base. And I'm going to tell you now, guys, for me, because this is GEC, I would simply do this. I know that the coefficient here is 1 and the coefficient here is 9 over 16. So I'm just going to quickly say 1 plus 9 over 16 in my beautiful calculator, and then voila, look at that, I get 25 over 16, the addition of the coefficients. The coefficient of y to the power 8 is 1, the coefficient of y to the power 8 here is 9 over 16, so I get 25 over 16. Put this in my wonderful square root. Now do you see what can happen? Now, the relationship between 25 and 16 is division. The relationship of 25 over 16 with y over 8 is multiplication. So what I can do now is I can say the square root of 25 over the square root of 16 with the square root of y to the power 8. And I think now, because we have multiplication and the splitting can happen, we have division and the splitting that can happen, there's no plus or minus sign, we are free to split. All right, we are free to do what? To split the square root. Then what's the square root of 25? Guys, it is 5. What is the square root of 16? It is 4. what is the square root of y to the power 8? When we remove the square root, we take the exponent 8 and we divide by 2. All right? That is why we get 5 over 4y to the power 4. Because that 8 divided by 2 gives us 4. So what I want to then express to you is that when you want to write a root as an exponent, a rational one, all you need to do is remove the root, the nth root, by taking whatever the nth root is, taking that exponent, you divide by the n. That's how you remove the what? The nth root. So then that's a to the power m over n. You converting the root into a exponential form. Where did I get 25? Remember, guys, we said y to the power 8 plus 9 over 16 y to the power 8. We said these are two terms and they are like terms. So if we have like terms, guys, y to the power 8 plus 9 over 16 y to the power 8. Thank you so much, Blazer, for the roses. These y to the power 8, we call them what? Like terms. What do we know about like terms, guys? GEC learners, grade 9. This is GEC, guys. Like terms, we can add and subtract. That's what we know about like terms. What do we do when we are adding or subtracting like terms? We keep the variable, meaning, in other words, this y to the power 8 and this y to the power 8 is going to be in our final answer. So we are going to keep that as it is. We are not going to change that, because like I said earlier on today, I said that like terms, the variable and its exponent basically gives us the like terms. That's how we identify like terms. Because there's y to the power 8 here for this term, there's y to the power 8 for this term. This means these are like terms. We can add and subtract like terms. Thank you so much for the rose, real guy. So that then means they have the same uniform. Y to the power 8 and y to the power 8 have the same uniform. We keep the uniform as it is. If you are in a school, you are having the same uniform, you are part of that school, you keep the uniform as it is. It does not change because you are adding two individuals, two terms. Now, when you are adding like terms, you keep the uniform, or the y to the power 8, you add the coefficients. So in other words, you are going to say 1 plus the 9 over 16. Guys, 1 plus 9 over 16. In grade 7, you did fractions. The LCD between 1 over 1 and 9 over 16, the LCD is 16, right? Then, what do you do to this denominator so that it can become like the LCD? You multiply it by 16. But what you do at the bottom, you do at the top. So this becomes 16 over 16. 1 over 1 becomes 16 over 16 because 1 over 1 is the equivalent fraction when the denominator is 16. Then what do you do to the 9 over 16? You times it by 1 top and bottom because the LCD agrees with what the 16 is here. So you multiply that by 1, you multiply by 1. That gives you 9 over 16. Then the rule says when you have the same denominators and fractions, what do you do to the numerator? You add. So the answer is 25 over 16. So that's where the 25 over 16 comes from. It comes from my what? My addition of 1 and 9 over 16. But since this is GEC, what did I do? I took my calculator, I punched in 1 plus 9 over 16, and I got 25 over 16 from the calculator. So here it is. Addition of the like terms inside the square root leads to what? Okay, leads to what? Yes, you do that. It leads to 25 over 16. then the variable still stays the same. The jersey, the uniform of the school is y to the power 8 because these are like terms. Next step, now I have 25 over 16. The relationship of 25 and 16 is divide, because this line stands for divide. This y to the power 8 is combined with 25 over 16, so it is like being multiplied to y to the power 8. So now we can split the what? The fraction according to the square root. We can say the square root of 25 over the square root of 16. Then y to the power 8, it is multiplied to 25 over 16, so we can also do what? Split it. Split it according to the square root of y to the power 8. Now we can evaluate square root of 25. What is the square root of 25? It is 5. The square root of 16, it is 4. The square root of y to the power 8, I said, guys, there is a rule that basically informs what we do with the square root of y to the power 8. We say y to the power 8, to remove the square root, we divide by 2. If it was the cube root, we would divide by 3. If it was the fourth root, we would divide by 4. If it was the fifth root, we would divide by 5. Okay? That's fine, Nati, that's fine, as long as we get to the answer. That's what we are interested in, because GEC, we are just selecting the option, we move on. Okay? So 8 divided by 2 gives us 4. Remember, guys, I am reinforcing to you guys these steps and showing you these steps, because as learners that are probably, some of you are going to decide to go and do pure maths next year in grade 10, you must ensure that you know how to reveal step by step what you did with a particular question, especially with simplifying, because your marks, you get them when you do that. So in as much I know it's GEC and it's multiple choice, but remember the skill of doing it step by step is very important. Okay, so yes, we divide by the given root, Sina, as you have said. So since here it is the square root, we are going to divide by 2. If it was the fourth root, we divide by 4. So that's why this rule is applicable. If you are having the nth root of a to the power m, what do? You say a to the power, you keep the exponent in the numerator that is there, you divide by whatever the root is there, and you get your answer. So that's why our final answer here is 5 over 4 y to the power 4. Then we go to our options, we go and check which one is available. Is it A? Is it B? Is it C? Is it D? So guys, you can see the answer. It's popping. It's in front of your face. You can see what option we would choose. You guys can see it, right? You can see the option because it is C, right? So yes, definitely you'll go to your booklet. In the space provided, you will write the letter C. Okay, so I hope you guys are fine now. There is like a clear understanding. This is important, guys. Okay, I can see the option Super Not Angel. I love the use of the English language there. No wonder Super Not Angel, you doing the things there. You know, I saw your video there where you were explaining where, you know, learners at your school are saying you speak English very well. Even in the platform, you speak English very well. So thank you so much there for that. That's, you know, I love the use of words there. Yeah. This is what we need. We need learners that can just munch everything up. Language, maths, science, everything. Okay, let's go on. Next question. Ooh, nice. Question 29. 4x minus 1 over 2, the whole thing squared. What is the product? Okay. What is the product? Let me just say, guys, to those who want me to repeat things, I unfortunately, it was the second time I was repeating that one. You guys will have to just go and check that out in the YouTube channel once I upload the video, and you are going to have to watch it in your own time. I don't want to make this video very long so that when people can get the chance to watch it in their own time, they can watch it and it's sufficient. Okay, so let's look at this one. What is the product of 4x minus 1, the whole thing squared? Now, this is very important. That's easy. Can you let me request and explain it all? Velile is like saying, guys, I don't allow any requesters. It's very, the requesting, it will munch up the time and all of that stuff. I don't want any requesters, so sorry, I'm not going to allow you for that. Use the comment section. But I'm sure you know what you know, and I'm happy that you know, and I'm sure that you know what you know. One day, guys, one day, hopefully one day, I'll have those people that are true maths gamers to actually join and request and all of those things. But for now, because we are pressed for time, I don't want to allow you that, you know. Sorry, guys, don't feel too, you know. Hopefully you, yeah. 4x minus 1 over 2, the whole thing squared. What is the product? Now, if you look at the options, guys, you know, depending on how clear you are about expressions and expanding, you will be very, 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 very interested to see the many options people can write, you know, which is very, very interesting. So let us jot this down. 4x minus 1, the whole thing squared. I'm sure you guys can see already in the comment section, there are different answers that people are giving. It's shocking. There's C, there's D, there's B, there's C, there's C, there's A, there's C, there's C, there's C, there's A, there's A, there's A. I feel like I can even do a song here. There's C, there's B, there's A, there's C, there's B, there's B, there's A, there's A, there's C, there's B, there's C, there's A, there's A. What? This person. You see this one? Stone 7, when you are here to play, when I'm going to chase you out. Stone 7. Stone 7 is saying F. What option do you see here being F? Alpha Gabi is saying you can help with the beat. For sure, my leader, for sure. So what is the common misconception? What is the thing that people do wrong when it comes to this? And I want to reveal to you the things that we get wrong with this question. Okay, so you can see people are saying many things, but I want us to please, let's leave this question knowing exactly what it is that we need to do, because people do things that are funny. So we have 4x minus 1 over 2. How many terms are inside the brackets? We have 2 terms inside the brackets, because the minus sign separates the 2 terms that are inside the brackets. That's the first thing. Secondly, what is this? This is an exponent. This exponent here is saying what to us? This exponent is saying, good sir, will you kindly open 2 brackets for us so that we can simplify this thing? That is what this exponent is saying to you and to me. And there's something noteworthy that we need to note here. Now that we've opened the 2 brackets, what do we now do? We apply something called FOIL. FOIL. We multiply the first term, the outer term, the inner term, and the last. First, outer, inner, last. First, and when we do this, guys, don't forget S for sign, N for number, L for letter. We multiply the sign, the number, the letter. 4x times 4x, you consider the sign when you are multiplying the first terms. Positive times a positive gives us a positive. 4 times 4 gives us 16. That is the number. Then x, the letter. X times x gives us x squared. We are done distributing 4x to 4x. Remember, x times x. The laws of exponents says when you are multiplying same bases, you are multiplying them. Remember, you keep the base, you add the exponents. There's a magical number 1 there, and there's a magical number 1 there. Okay, very, very important. 16x squared. Lusanda, no, we do not make use of law number 4. No, no, no. Guys, please take note. Lusanda has commented there. That's a very, I love Lusanda. Lusanda, I love you for commenting and saying this. Lusanda, we don't. We don't. Okay. That law only applies when, if between two bases, the relationship is multiply, and if the relationship between the bases is what? Is divide. You see, guys, when that is the case, what Lusanda has said becomes true. If the relationship between the bases is multiply, we simply multiply the exponents. All right? When the relationship a over b raised to another exponent, there's an exponent on the other side, then we multiply the exponents. We do that with multiplication of bases and division of different bases. But guys, with addition and subtraction, can I tell you now, and I want to tell you now, and I want you to never forget it, to take this p and multiply it here, and then to take this p and multiply it there, but there's a plus and a minus sign in between. That is absolute nonsense. We do not do it. Okay? This is for exponents. The law that Lusanda was talking about is this law that says if you have a base raised to a certain exponent, then you multiply the exponents, all right? But this applies when the bases are multiplied with each other or divided with each other. Okay? It does not apply when there's a plus and a minus sign between the bases. It does not apply. It is nonsense to apply it when there's a plus and a minus sign. So we don't do this for plus and minus sign. We don't do that. This here, guys, is wrong. Okay? We don't do this. This here, absolutely wrong. Okay? So for plus and minus, if there's a plus and minus sign between the terms, we do not multiply the exponents. We only do it with multiplication and division. This is a common misconception that learners make, which makes, can I tell you this, guys? This kind of mistake is done so much by learners. Okay? Yeah. And I love someone what he's saying in the comment section. Sine is saying, it is similar to the fact that we do not split, all right, the root for when there's a plus and a minus sign between the what? Between the terms. We don't split. It's nonsense to do so. Okay? We don't. It's wrong to split for what? When there's a plus and a minus. Okay? But when there's a divide and a multiply, splitting can happen. So you can distribute the exponent by multiplication if there's a multiply and a divide between the bases. But if there's a plus and a minus sign, you can't. No, you can't, Velile. We don't. Okay? So that is why in this problem, what did I say we must do? This is 4x minus 1 over 2. There's a minus sign separating 4x and a half. So what do? We open two brackets. Okay? We open two brackets. Okay? So Bopilo Mohotu is saying, can you explain briefly? Bopilo, the basis of that law is this. If you have a base raised to an exponent and it's raised to another exponent, the law says you multiply okay, the exponents. Are we together? Now, furthermore, if you have a base raised to an exponent and you have another different base raised to another exponent, and the relationship between the bases is multiply, okay, and it's all raised to another exponent, then what you can do, because these bases, okay, are multiplied together. Remember, guys, multiplication combines the terms. Because the terms are combined, A and B are actually combined, you can apply the exponent by multiplication to each respective base and its exponent. That's why the answer here is A to the power m times P, B to the power n times P. This is fine and it is acceptable for what? For the multiplication of bases. So multiplication, it's fine. Then what about for division? Same thing. This law can be applied even for division of different bases. You have A to the power m over B to the power n. They are both raised to the power P. So once again, we can distribute the exponent to m, A to the power m times P. We can distribute this exponent P to the n, B to the power n times P. That's okay. For division, we are okay with doing that. The problem, though, always reveals itself when we have a plus and a minus sign between the what? The terms. We don't. These are different terms. Are you with me? So therefore we cannot. We absolutely can't take this A to the power m and multiply with that P. And then write A to the power m times P plus my B to the power n times P. Rubbish. Nonsense. So we leave it as it is. Okay, I hope you understand. So here we are given now, right, a specific, right, 4x minus half. There is a what? There is a squared. Okay, I hope you understand. 4x minus half, the whole thing to the power 2. So here, what we do is we open two brackets. Why are we opening two brackets? It's because we can see there's an exponent 2. This is saying repeat. What are we repeating? We're repeating twice this expression, 4x minus half. So we say 4x minus half into 4x minus half. Now that allows us to then apply a method of doing what? We take 4x, we distribute him to the first term. We take the very same 4x, we distribute him to the second term. So this is what we call FOIL. We multiply the first terms of each bracket. That's why we have F for FOIL, which means first. When we do that, we apply S, N, L. In other words, we multiply the sign, we multiply the number, we multiply the letter. That ensures that for each term we get, we are getting the full answer. So let's multiply. Positive 4 times positive 4. That gives us 16. Let's sort out the sign, positive, and the number, which is 16. Then we multiply the letter. What's x times x? Guys, from your laws of exponents, any base that are the same that you multiply together, what do you do to the exponents? You add the exponents whilst keeping the base. So here we have it. X times x, we know is raised to the power 1 to the power 1. That means when you are multiplying same bases, you keep the base, you add the exponents. So our answer for the first term is 16x squared. Do you all understand how we got 16x squared? I hope we do. We keep the base, x, we add the exponent, so it becomes x to the power 2. Then we move on. We take the same 4x. Now we are going to multiply with a negative half. Applying what? S and L. S and L. So let's first multiply the sign. What is a positive times a negative? That gives us a negative. Sign is sorted. We move on to the number. What's 4 times half? 4 times half. You see, it's become easier when you look at it that way. What's 4 times half? Guys, 4 times half is actually equal to 2. 4 times half is 2. Right? So you now have the sign there. It is just 2. You've got the number. Tick the number. Then you move on to the letter. What's there as the letter? It's x times what? There's no other letter. So x times what? Times 1. What's x times 1? It's x. So just write the x next door. It's combined. We are done with our first terms and our outer terms, multiplying them. Now we take negative half, we distribute to 4x. We do the same thing. We apply who? S and L. Mamo, how do I get negative 2? Listen to me. I said firstly, positive times a negative, and I got a negative. Then, that's the sign. Then we follow the number. 4 times a half. What is 4 times half? We got a positive 2. So that means after the negative, we are going to write 2, which means our sign and number is negative 2 when we multiply 4, that is positive, times negative half. Then after that, we check the letter. X times, we don't have any other letter here. So that means 4x times half. We know that the letter that we will write is just the letter x. So we get negative 2x as our answer when we multiply 4x times negative half. Turn our attention now to negative half times 4x. Do the same thing. What's a negative times a positive? That is a negative. What is half times 4? That is 2. Then the x is the only letter that's there. We combine and attach the x to that specific numerical negative 2 coefficient. Then last thing we do now is we take negative half and we distribute it to the other negative half. And we apply S and L. What's a negative times a negative, guys? It is a positive. What's a half times a half? That gives us 1/4. So I hope we are all clear as to how we got to this step. Any questions, guys, that you have as to how we got here? Are we good? Can we move on? Are we clear? Next step. Okay. I see people like Rofunwa, Hashal, can you go over it once more? Guys, are we listening, like really and truly? If you are saying, let me go over it once more, my question to you, are you listening? Are you listening? Are you guys listening? Some of you, I don't know if you are really listening, to be honest. Okay? And I don't know if maybe, did you even understand this in the beginning? Were you understanding it when you were taught? Because that's $1 million question. I see the people who are saying we understand and who are fine. All right? Which means you are following along. But the question is, are we listening to this? And did we even get it when we were doing it at school? Okay? So now that we are here, we are going to add the like terms. Okay? Thank you, Cairo. Oh, Cairo. Wela Cairo. You are here, my brother from another mother. Thank you so much for the roses, mom. Hi, when you are funny. All right, so this last so here, guys, what do we see? We see there are like terms here. There are like terms. So like terms, we know we can add and subtract. All right, 16x squared is not like any other term that's here. Why? Because the variable of 16x squared, the variable has an exponent that is 2. Okay, this negative 2x minus 2x, these are like terms. So therefore, what does that mean? We keep the variable x as it is, because it is like that school uniform I was talking about. These are learners from the same school. There's x and x, which means they are wearing the same uniform. So all that you do is you are going to add and subtract the coefficients. So what's negative 2 minus 2? That is equal to negative 4, which is why I say when you are adding like terms, we keep the variable, we add the coefficients or subtract them. So negative 2 minus 2 is negative 4. Then that 1 over 4 is unique. It does not have a like term. These are all unlike terms. 16x squared is different from negative 4x, is different from a quarter. So we end right there. We cannot add these together. I see some learners adding these things together and I'm like, guys, we can't add like terms, unlike terms. Unlike terms, we cannot add. Okay. Yeah, I know, Zimkita, you thought the letter A is going to be the answer. You were sadly mistaken. The answer, guys, look, this. Who does this look like? Look at the options. Is it this? No. Is it that? No. Is it that? Hey, it is B, guys. And you saw when I was asking the question, so many of you wrote C. I was like, what? Yeah. And those who said D, what the? No, it's not D. It's C. C is the answer. Yo, guys. Hey. Okay, guys, unfortunately, that's as far as I can go as far as that question is concerned. If you guys are having problems with multiplying out, it will become very important for you to go back to your notes, the ones that you wrote at school, and the examples and the exercises that you did when you were at school. Go recap on the steps of basically multiplying this out. But this was very simple, guys. The answer, my good people, is B. 16x squared minus 4x plus 1 over 4. That is our answer, guys. All right, and I hope that is clear. Okay, no, I'm not gonna do complicated ones. I'm going to do the ones that are here in this particular this particular question paper, GEC. Okay, look at this one now. We have this question that's following this one. Okay, I don't know what's going to be in the paper specifically, guys. I'm doing a past paper so that we can get familiarized with some of the types of questions we can expect. But you cannot limit yourself to these ones and think, that's probably what's going to come out. It may or may not come out. But at the end of the day, we just need to make sure that we revise our year's work for paper 1. Okay, so 9p squared minus 8q over r. What is the numerical value of the expression if p is negative 1, q is 0,125, and r is equal to half? Is it A, 4, B, 7, C, 16, or is it D, 20? I see in the comment section we have C, C, D. We've got A. Many people are saying A, some are saying D, some are saying C. Hopefully you've done the things that need to be done in order to check. So first and foremost, let us write down that 9p squared minus 8q over r, so that after that, in the place of p, who is supposed to feature? It is negative 1. In the place of q, who's supposed to feature? 0,125. In the place of r, who's supposed to feature? A half. So what we do when we write these numbers, we write them in the place of the letters, and we use what to write them in the place of the letters. What do we use to write in the place of those letters? We use brackets. We put brackets to substitute these numbers in the place of the letter. We substitute using brackets, please guys, which is why easily you could take this and actually punch it into your calculator the way that you would substitute it. So for instance, I would probably do this. Go to my fraction option that is there, voila, then press 9 and then put my brackets there. 9 into p. What's p? They said p is -1. So because I try, this is all in the name of trying to make things easy. 9 brackets -1, I put the square there. Remember the square, let's just delete, put the square there, there it is. You can see mostly. Then we minus, just make sure that when you minus, you have brought down the cursor so that the minus is not in the exponent, but the minus is definitely in line with the expression. You minus the 8, you write 8, and then in the place of q, what would you write? Q, 0,125, 0,125, you close the bracket. Then in the denominator, you go down there. Then in the place of r, what are you going to write? Half. Now guys, I know a half in decimal form is actually 0,5. Just trying to make life easy for myself, because having the half as a fraction, may just complicate my life. So I know half is 0,5. How do I know that? I know that because, guys, I know how to convert fractions into decimals, decimals into fractions. So my experience has been able to lead me to know that that is the case. Look at the answer that I get. I get the value of 16. Now I hope that's all that you got, guys. You got 16 as well. It is C. The answer is C. Many people said A, some said B, some said many things, but in actual fact, guys, the answer is C. The answer is C. C is the answer. C is the answer. How did I get C? Guys, I used my beautiful calculator. I didn't waste my time. Don't spend too much time in this question. I just used my calculator. I substituted everything in there. I got C. Very good. Very good. Very good. Syntax for you, probably, because why? I tell you why you probably got syntax error. Let me just go here. Let's go down here. Let's say I had decided to put the fraction 1/2. Oh, well, you know what? What do you have here? I still get 16. Okay. If you calculate by yourself, you get 4. Now, that's very interesting. All right. Let's check that, because someone else is saying if you calculate by yourself, you get 4. Now, I want to dispel that rumor. So in the place of p, we write -1 squared minus 8 into the q. This is q 0,125. All right. In the place of q, we write 0,125. Then over r, in the place of r, what do we get? In the place of r, we write half. Okay. So let's take it one step at a time. How many terms in the numerator? Okay, we actually have how many terms, guys? We have 2 terms in the numerator. -1, the whole thing squared. Remember, bad maths. What does bad maths say? We start with the brackets, followed by the exponents, then division, then multiplication, then addition, then subtraction. So -1 squared, when you apply a square to the sign negative, it becomes positive. So this is the same thing as 9 times 1. Minus the 8. Now 0,125, guys, I believe as a fraction, 0,125, you go there, you say 0,125, you say equal, you get a nice fraction there of 1/8. So 8 into 1/8. You'll be very interested to see what the answer is there. Okay, that's 1/8, and 8 times 1/8 gives us something. What's 9 times 1 is 9 minus, what's 8 times 1/8? That's 1. Over 1/2. 9 minus 1 gives us 8. 8 divided by half. Hi, guys, this should be easy. 8 divided by half is the same thing as 8 times 2 over 1. What is it? It's 16. So the person who said when they calculated it, they got 4. How? Yeah. Guys, okay. Yeah. So please, in your calculator, some of you, if you got B, you did not put everything in brackets. Please, guys, put 9 brackets -1 squared minus 8 brackets 0.125, okay, over half, okay, are you with me? Okay, please, otherwise then 9 times 1 is 9, 8 times 1 over 8 is 1, 9 minus 1 is 8. This is a half in the denominator. What is 8 divided by half? 8 divided by half is the same thing as 8 divided by half. You change the divide to multiply. What happens to the second fraction? It inverts. You can write it as 2 over 1. What's 8 times 2? This is 16. Okay. How are we supposed to do such a long paper in 2 hours? Lusanda, remember, I am explaining here, but you can do this question paper and answer it under 2.5 hours. That is for sure. If you know your stuff, if you know your maths, then there is no reason why you shouldn't be able to finish this in less than 2.5 hours. Because remember, I am doing it and explaining it. If I was silent and I was keeping quiet and I was just doing my work and obviously selecting the options, then it would be easy. There are certain questions you'll be able, like for this one, I would quickly do this in my calculator and get the answer without having to actually do this step by step on the side, then selecting the answer. So obviously this would be C. And you guys saw me when I did it in the calculator. I simply substituted the values in the place of P, Q, and R, and then I pressed equal. Just make sure when you substitute, you use brackets, and you make sure, guys, that you do things in the right way. Don't insert numbers that are incorrect. Remember, they said P is -1. So in the place of P, what did you do? You wrote -1, the whole thing squared, minus 8. They said Q is 0.125. In the place of Q, you wrote in brackets 0.125. They said R is half. In the place of R, you wrote half. Then after that, what did you do? You applied the exponent to the -1, because BEDMAS, which is the order in which you do things when you have many different operations, BEDMAS means brackets. We start with what is in brackets. So this -1, then we are followed by what? The exponent. Then D means division. All right, then M multiplication, A addition, S subtraction. So this -1 squared becomes 1. Then this 9 times 1 gives us 9. Okay, then here -8, 0.125 is actually 1 over 8. Okay, then the 8 times 1 over 8, what does it do? It gives us 1. So 9 minus 1 gives us 8 there. Then we have half in the denominator. Guys, like I said, if you put this first step in your calculator, you would get the answer. Put this in your calculator, you'll get the answer. Surely, very easy. All right. Okay. So unfortunately, me has to move right along on. Let's look at this next question. Hello, hi. Factorize 25a squared minus 16b. Okay, factorize 25a squared minus 16b squared. Those who are joining in for the first time, guys, I've already done the previous questions, question 1 up until 20 or so. I'm busy with these ones now, so that will actually develop the new video that I'll be posting onto the YouTube channel. these videos that I do, the live lesson itself, I download it from TikTok and then I post it into the YouTube channel. So if you want to go and see what I've done previously for the previous questions, you're more than welcome to go to the link in my bio. You'll see it. It's YouTube Maths is a Game. You can just click on there, go to the YouTube channel. There is a playlist that is for GEC exclusively, GEC 2023 and 2024. The YouTube channel is Maths is a Game. You can then watch everything that I've done so far, and you can fast forward times to it as much as you want so that you can get to where you want to get to. And obviously just make sure that you are able to get those answers that you need where you need them. Okay, so A, we need to factorize 25a squared minus 16b squared. So what type of factorization do we apply in a question such as this? All right, so hopefully we know, guys, the different types of factorization. We've got highest common factor, all right, where we take out a highest common factor. We've got dots. Quentin, very good. Dots meaning a difference. Difference means subtraction. Then of two perfect squares, guys. Okay, we've got grouping, we've got trinomial factorization, we've got common bracket factorization, we've got cubic factorization in grade 10, that is, though. In grade 9, we just have those ones: grouping, difference of two squares, trinomial factorization, and that's pretty much the type of factorizations that we have for grade 9. Okay, 25a squared minus 16b squared, so this is a difference. Then 25 is what we call a perfect square number. A squared is also a perfect square because it is a variable raised to an even exponent. Any variable raised to an even exponent, guys, is what we call a perfect square variable. Yes, I'm going to be live tomorrow. B squared and 16. 16 is a perfect square number, and b squared is also a perfect square variable because it is a variable or a letter raised to an even exponent. Okay, so I hope that makes sense. So now, simply put, we are going to take this 25a squared minus the 16b squared and see what type of factorization helps there. Which one? Well, we know most that when we factorize this, what do we do? 5 a.m. guys is when I go live, all right? 5 a.m. in the morning, and then during the course of the day, I'll have to see. So first and foremost, when it's a difference of two squares, we always write a plus and a minus sign for each bracket. That's the first step. Okay. How do we determine what type of factorizing? Specifically for this one, guys, we can see that here we usually ask the first step always when we are factorizing. We check, is there a highest common factor? Now, guys, for 25a squared minus 16b squared, the highest common factor is 1. But taking out the number 1 does not change the expression at all. So we regard that as insignificant, taking out 1 as a highest common factor. Okay, then we look, if highest common factor is just 1, then we look any other type of factorization. Okay, we check difference of two squares. Is there difference of two squares factorization? In actual fact, we can see there is. There's a difference here, and then 25 is a perfect square, a squared is a perfect square, so that means this term is a perfect square. So two squares, guys, this is a perfect square, and then 16b squared is also a perfect square. So that's how in this situation you can quickly decide, oh, this is a difference of two squares, because after taking out the highest common factor, which is 1, we can see that, is it a difference of two squares? Yes, it is. Okay, we check those, guys. We check those types of factorization. Grouping usually applies when we have an even number of terms, right? If we have 4 terms, 6 terms, 8 terms, we always check if there are 2 terms that we can take out a common highest common factor that will lead to a common bracket. Okay, so that's why we usually talk about common bracket factorization as well. Okay, so anyways, 25a squared minus 16b squared, we take the square root of 25a squared. What is the square root of 25a squared? By now, guys, we should know, because when we split these, what do we get? What's the square root of 25? It is 5. What is the square root of a squared? Guys, 2 divided by 2 for our exponent. That means we have 5 what? 5a. Okay, so what you do is you populate 5a for your first term in each bracket. Okay, because what happens when you multiply 5a with 5a? Do you get that 25a squared back? Yes, you do. Next step, we take the square root of 16b squared. Obviously, that means split, because we can, applying that law. So the answer is 4b to the power 2 over 2, which means the answer is 4b. Okay, so we populate the second term with 4b. This plus and minus sign are relevant because a positive times a negative will give us this negative sign. And the multiplication of this and that gives us 20ab, which is positive, whereas the multiplication of that and that gives us a negative 20ab, which basically means our middle term, we are not going to have 1 because it will be 0. That's why 25a squared minus 16b squared is factorized in this way. A difference of what? Of 2 perfect squares. You always have a first term bracket being positive and the second bracket being negative. Then you take the square root of each independently so that you can get the first term of each bracket from the square root of the first term, the second term of each bracket from the square root of the second term. And that's how you factorize a difference of 2 squares. If we look at these brackets together, we cannot factorize any further. Okay, that's fine. That's fine. You are saying to me, in the answer, our first term has the negative sign. Guys, that's fine. Do we have a 5a minus 4b here? Yes, we do. Do we have a 5a minus 4b there? Yes, we do. Do we have a 5a plus 4b here? Yes, we do. Do we have a 5a plus 4b there? Yes, we do. What is the relationship of these brackets? The relationship of these brackets is multiply. Isn't a times b the same thing as b times a? Yes, it is. What do we call that? We call that the commutative property of multiplication. What does commutative mean? Commutative means that the order in which you place things when multiplying does not matter. The order in which you place things with multiply does not matter. So that means 3 times 2 is the same thing as 2 times 3. As it is, of course, because that is the commutative property of multiplication. Just like addition as well, there's the commutative property of addition, because 3 plus 2 is the same thing as 2 plus 3. So addition and multiplication, we say, are commutative. So if you start with the negative bracket, that's fine. If you end with the positive bracket, that's fine, as long as you have both. So the answer, yes, is A. That's fine. Okay, does that make sense, guys? So the answer is A. It is not B, it is not C, and it definitely is not D, because none of these options resembles the factorization of 25a squared minus 16b squared. Now to Zahid Ismail, who is asking what is additive and multiplicative. Guys, additive inverse. Let me just give you an example. Additive inverse is simply this. If I give you 4 and I ask you, what is the additive inverse of 4? Then what I'm asking you is, what is the fill in the blank, the number which I will basically have 4 will be added to it, that will give me 0. Any additive inverse to another number should give me, when I take these two together, should give me 0. So what is that number? That's my question to you. You tell me, fill in the blank. So the additive inverse of 4, as Lusanda says, is what? is negative 4. That's what an additive inverse is. If I put this here, minus 3 plus what? Blank will give me 0. Remember, I said an additive inverse is that number that will be added to another number which will lead to 0. So what is that number? Yes, guys, it is 3. So that is what a additive inverse is. Now let's answer this next question. What is a multiplicative inverse? Okay, because that's what you were asking as well, Zahid. What is a multiplicative inverse? If I give you 5 and then I ask you, what is the multiplicative inverse of 5? In other words, what you are saying is, what can you multiply to 5 which will give you 1? That's what you are asking. What can you multiply to 5 which will give you 1? That's the question you are asking. Fill in the blanks. Morena is saying 1. You are wrong, Morena. Hashal is saying 1. You are wrong, Hashal. Oza Alisa is saying 1. You are wrong. Lasanda, you are wrong. Alpha, you are wrong. Hlatse, you are absolutely right. Thank you, Hlatse. Hlatse is the goat of the evening. Hlatse is the goat of the evening. Hlatse is the goat of the evening. It is 1/5. What are we saying, in other words, by saying this? We are saying that 5 as a number can be written as 5/1. Do we all know that 5 as a number can be written as 5/1? Did we know that? Did we know that 5 as a number can be written as 5/1? This is a fraction. It is a rational number. Now, I am asking you, what do we multiply to 5 to get 1? That's the question. So the number that you get here, what did you do to it? You flip the fraction. Flip the fraction. We are flipping. 1 becomes the numerator. 5 becomes the denominator. When you multiply these two together, you get 1. That's what we mean, guys. 5 becomes the denominator. 1 becomes the numerator. So if you want the multiplicative inverse of 5, the answer is 1/5. If I want the multiplicative inverse of 3/7, let's see you in the comment section. If I want the multiplicative inverse of 3/7, what we are asking is, what can we multiply to 3/7 to get 1? Amyoli, you are amazing. Amyoli, the multiplicative inverse of 3/7 is what? 7/3. All right, you guys get the point. So please understand, when you want the additive inverse, you want that number that you can add to another to give you 0. When you want the multiplicative inverse, you want that number that you can multiply to another to get 1. So when I say what is the multiplicative inverse of 5, the multiplicative, understand what is 5 as a fraction. It is 5/1. What is 5 as a fraction? It is 5/1. And therefore, what is the multiplicative inverse of 5/1? Flippity flip, flippity flip, flippity flip. We play flippity flip. Flippity flip the fraction. 5 goes into the denominator. 1 goes to the numerator. And then we have 1/5. Make sense? What is the multiplicative inverse of 3/7? Well, flippity flip, flippity flip. We flip the fraction. 7 goes to the numerator, 3 goes to the denominator. The answer is 7/3. Okay, so that's what we mean by multiplicative inverse. That which we multiply to another to get 1. by additive inverse, that which we add to another to get 0. Okay, I hope you understand that part. Okay, let's move on. Next question. Factorize y squared minus 11y plus 28. Y squared minus 11y plus 28. Thank you, Lusanda. Y squared minus 11y plus 8. Okay, yes, Mkita Nobeta, we have those two inverses, multiplicative inverse and additive inverse. These are the inverses we use when we are solving a equation, guys. When we are solving an equation, we are using those inverses, guys. That's what we are using all the time. So here, y squared minus 11y plus 28. Okay, I hope you understand that. Yes, I do in my YouTube channel, guys. You can check out those. Link is in my bio for the YouTube channel. I have a playlist. Just go to the playlist there in the YouTube channel. Go subscribe. Go to the playlist. My playlist there. GEC. I have GEC 2022. Go to the playlist. You'll see it. GEC 2023 and 2024. I've only done part 1, part 2, and part 3. And that's still the questions behind question 32. I haven't done the rest of this paper, so I'm still progressing with my part 1, part 2, part 3, and so forth. It's got meaty explanation. I explain the questions. That's why those videos are long, because it's like I am teaching you the work that you're supposed to be reminded for before you write the paper. Okay. Yes, it will be on the YouTube channel, what I'm doing now. I will post it after the live session is done. I will post this very same video, as crazy as it is. I don't care, guys. Don't compare me with someone. Kevin Metz is Kevin Metz. Please, guys, please, please, please. I love Kevin Metz in science. He is the goat of the goats of the goats. And I plead with you, if you are here comparing me with him, please go to the channel for Kevin Metz in science and go and get the best of the best. I do not keep you away from that. But please don't come here and say comments that are basically comparing me with him. It does not help the situation. All right, please don't do that. You're right. You'd rather go there and enjoy there, please, guys. All right, please, please, please don't come here and do funny stuff in the comment section. Y squared minus 11y plus 28. So here, what are we going to do when we are factorizing? Y squared minus 11y plus 28. Okay, I need you guys to first understand. I see the answers there, which is great, and I'm sure you guys can see that the answers are there. So y squared minus 11y plus 28. If we are factorizing a trinomial, first step we always do is we check, is there a highest common factor? Okay, is there a highest common factor here? Well, if you look at the first, second, and third term, yes, the highest common factor is 1, but 1 does not really have significance in the expression. So what we are going to do for this trinomial, we are going to open 2 brackets. Whilst doing that, please understand, the 1 that is the highest common factor is actually outside there. We don't see it, but it's there. All right, that highest common factor, that is 1, is actually outside there, unseeable as it is. Then we have a constant term that is positive. Guys, when you have a constant term that is positive, that means you are going to have the same signs inside the bracket. I repeat, when you have a constant term that is positive, that says to you, you are going to have the same signs inside the bracket. According to who? According to the sign of the middle term, right? If you have a positive constant term, it means you are going to have the same signs inside the bracket. According to who? According to the sign of the middle term. So I can tell you from the get-go that in this bracket and that bracket, we are going to have a negative and a negative. I repeat, When you have a positive constant term for your expression that is a trinomial where y has a positive coefficient that is 1, then it means that the signs inside your bracket will both be according to the sign of the middle term. Positive means same signs according to who? According to the sign of the middle term. So we have a negative and a negative. That is something that we know for a fact. Then y squared. How is y squared formed? It is y and y, because y times y will give you y squared. Then for 28, you are going to think about the factors of 28, which when you multiply give you 28, but when you add them together, as negative as both they will be, you will get negative 11. So you know you have 14 and 2, you have 28 and 1, you have 7 and 4, and many others. But the one that works the best, you know that both signs will be negative. Which one, when you add together, gives you negative 11? Is it negative 14 and negative 2? Well, when I add those together, I get negative 16, so it can't be that one. Is it negative 28 minus 1? When I add those two, I get negative 29. It can't be that. Is it negative 4 and negative 7 and negative 4? Well, it definitely must be. So that means these are the terms that I'm going to actually take. So it's 7 and 4. Whether you start with 4 guys or end with 7 doesn't matter, because these brackets have both got a negative sign. Does the order of the brackets matter? No, it doesn't. Whether you start with y minus 4 and end with y minus 7, or start with y minus 7 and end with y minus 4, does not matter. Why? Because multiplication, as we said, is commutative. The order of the brackets don't matter, because it still retains its identity. So is it A? No, the signs are different. Is it B? The signs are the same, but they are not according to the sign of the middle term. They are positive. No. Is it C? Well, it definitely resonates with my answer. So C is the viable option. Definitely letter C is the answer. Okay, smooth, right? Very smooth. So very important, this thing about factorizing a trinomial. Okay, take out the highest common factor if there is one. In this case, obviously it was 1, and then after taking out the highest common factor, you can factorize the remaining trinomial with the coefficient the coefficient of 1 that is positive. Okay, if the constant is negative, imangetoti, let's just say we had another question here. Y plus 3y minus 4. Let's just say that was the case. If the constant is negative, what does it mean, guys? It means that the constant that is negative, that means that our signs are going to be different inside the bracket. Different signs. But take note, we look at the sign of the middle term. And if the sign of the middle term is positive, the highest factor that we choose will have the sign of the middle term. I repeat, the highest factor that we choose, we're going to choose factors of 4 most. The highest factor out of these factors of 4 will have the sign of that middle term. Okay? Yeah. So, for instance, let's just check this example. We would obviously open 2 brackets. Our y and our y would be there. Our signs will be obviously going to be different. And the sign of the highest factor will be positive. So I'm going to say positive, negative. Okay, does that make sense? Then after that, I'm going to check for the factors of 4. We have 4 and 1. We've got 2 and 2. Then the sign of the highest factor, we said, is going to have the sign of the middle term. So that's positive, negative, positive, negative. Obviously, these signs are the same here. So, I mean, the terms, the numbers are the same. So there's no highest one, right? So 2 minus 2 gives us 0. That's not the 3 that we have there. 4 minus 1 gives you 3. So this one works, okay? Plus 4 minus 1. Plus 4 minus 1. Notando, it's not my network. It must be yours. My network is 100% fine. So I think something is happening with your network. So therefore, when we factorize, that's how we would go about it. So please, guys, when a constant term is negative, you have what inside your bracket? Different signs. But the highest factor will have the sign of whatever the middle term is. So since this is positive, we know that the sign of the middle term of the highest factor is going to be positive. But if this was negative, that would mean that the sign of the highest factor would be negative whenever we have a negative constant term. Okay, I hope it makes sense, guys. I hope it makes sense. Let's move on. What if the variables are not the same? Well, guys, when the variables are not the same, like for instance, something like this, and it happens, right? X squared plus 2xy minus y squared. As you can see here, this is an x squared term. This is a y squared term. All right. Actually, let's just say, sorry. Okay. So once again, we can factorize this, right? We can factorize it. We are going to also open 2 brackets because we can see this is a quadratic trinomial. The square term, the square term. Okay. So obviously then, plus for the last term means that we're going to have the same signs inside the bracket according to the sign of the middle term. So that means that's plus and plus. Now, this is y squared. How do we form y squared? Y and y forms y squared. Okay, the coefficient of the y squared is 1. All right, so that means we have x and x for x squared, and it's very much apparent here that this y times y does give us y squared, which is basically the answer there. And obviously the 2xy we will actually be able to get when we add the 1 and the 1 together. All right, then obviously the xy, we will get it most. Okay, we will get it most whenever we multiply xy plus another xy. That will give us the 2xy that we need as our middle term. Okay, so that works out nicely. All right, so just always check the situation, whatever the situation is. When things are factorizable, you can definitely factorize them, but when they are not, they are not. Let's look at 3.3. Factorize. Look at 33, guys. I'm saying 3.3. 33, I mean, not 3.3, 33. Okay. Factorize. I think I'll be finishing at 11, guys. Unfortunately, or fortunately or unfortunately for you, I know some of you need to go and sleep. Please do remember, I'll be posting this on the YouTube channel, so you can go and sleep if you are going to take the time to go and at least watch, all right, that last remaining part that you didn't get a chance to watch. So that's fine. So 9p squared plus 27p minus 90 is equal to, there are the options. Okay, now I would obviously then say to you, you think it's B. Okay, I see you saying it, you think it's B. So let's go ahead and come here first and ask ourselves the fundamental questions. It's Maths is a Game. That's the name of the YouTube channel. The link of the YouTube channel is in my bio, kid. In my bio, you can find the link of the YouTube channel. You can just click on there. It's a clickable link and it can send you there. Or if you can't click and be sent there, you can always copy the link and paste it on your Google search engine and search from the Google search engine for the YouTube page, right? With the link posted or pasted there on the Google search engine. So 9p squared plus 27p minus 90. We start by first asking how many terms. So how many terms do we have in the expression? I hope you can see how many terms we have in the expression. There are 1, 2, 3 terms. Is the highest common factor? Is the next question. Is the highest common factor? We take it out according to the sign, the number, and the letter. So the first term is positive, which means the sign is positive. Between 9, 27, and 90, the highest number, the highest common factor number is 9. Do we have a letter that's common? No, we don't, because P as the letter is not common for all 3 terms. So that means our highest common factor, we can take it out, is 9. We open a bracket. Then what remains? 9 times what gives you P? 9P squared. This is P squared. Okay. 9 times what gives you 27P. That is going to be 3P. 9 times positive 3, 27. Next door, we put the P. Then lastly, 9 times what gives you negative 90. I like what Lusanda has said in the comment section. Guys, no time to sleep. We want to pass so we can celebrate in December. And then she has like these fiery flames. I unfortunately don't know how to approve the comment. Actually, it's unapprovable because I tried, and it seems like many of your comments have actually passed by without approval. Okay. Then lastly, 9 times what gives us negative 90? Very good. Negative 10. Okay. Then next step, we open 2 brackets. Right? Now you can see the constant term is negative 10. So that means what for our signs inside the bracket? We are going to have different signs. And the highest factor of the factors is going to have positive. So that means we are going to have plus, minus, different signs. And already you guys have discovered the factors of 10. 10 and 1 is not going to work. It's 5 and 2 that is going to work, because 5 minus 2 gives us the 3. Okay, very good. Then we have P and P, and that is as far as we can factorize. There's nothing more that we can factorize. We look at this bracket, you can't factorize it further. You look at this bracket, you can't factorize it any further. So this answer agrees with which one? 9 into P minus 2 into P plus 5. Okay, so there it is. Okay, 9 into P minus 2 into P plus 5. Wizard, you are saying I can't understand, sir. What part can't you understand, Wizard? Okay, I don't know what kind of word, that name that you have there. You're calling yourself Wizard. Skibidi nigger. What? My goodness, these guys. People are naming themselves Skibidi nigger. What the? Alright. So please, guys, 9P squared plus 27P minus 90. As I said, we first take out the highest common factor, which is 9. All right, 9 is a highest common factor for all 3 terms. 9 is the highest common factor. It is positive 9. All right, after taking out the 9, you open the brackets, skibidi nigger. Then you are left with what for the first term after taking out 9? You are left with P squared. Okay. Then for the second term, you've taken out the 9. The question is, what are you left with for the second term? 9 times what gives you 27? It is 3. Then 9 times what gives you the P? Well, you need to include a P for the second term. Okay. I hope you understand. So plus 3P. Then lastly, 9 times what gives you 90? Negative 90. Okay, so that means it's negative 10. Or you can say negative 90 divided by 9, which gives you negative 10. So that's how you get your 3 terms after taking out the highest common factor, that is 9. You then close the brackets. After doing that, the next step, okay, for the brackets, I said to you guys that the minus sign for a constant term means what? We are going to have different signs in the bracket. That's what a minus sign means. A negative constant term means we are going to have different signs in the bracket. But because we have a positive sign there for the middle term, that means that the highest factor for our factors of 10 and 1, 5 and 2, the highest factor from our factors of 10 is going to have a positive sign, which means the other one is going to be negative. So that means then which factors will we be choosing to put inside the bracket? 10 minus 1, that gives you 9. Even though 10 times negative 1 gives you negative 10, 10 minus 1 gives you 9. This one is not going to work. We don't even think about it. 5 minus 2 gives you 3. The addition of these two gives you the coefficient of the middle term. So that means this one will work. All right. So that's why I put 5 in one bracket and negative 2 in the other bracket, because I can clearly see that it is 5 minus 2 that gives us the 3, which is the coefficient of the p that we want. Remember guys, whether you say minus 2 plus 5 still, that still gives you 3. So whether you put plus 5 here and minus 2 there, or put minus 2 there and plus 5 there, is of no real significance, because the brackets mean multiply, and we know that multiplication is commutative. The order in which the brackets are placed don't matter at all. Okay, I hope that makes sense. Now Mr. Wizard, I don't know if you are wizarding or you are wickedy wick. Do we have to rearrange if the constant is in the middle? Say yes. Remember, your trinomial must be in descending powers of p. If the variable is p, descending powers of p. If the variable is s, descending powers. What do I mean by descending powers of p? It means that your square term must be followed by your p to the one term followed by your constant. That's what we mean by descending powers. So if they give you a trinomial expression where the order is mixed up, you first rearrange the order. You make sure that the square term is followed by the to the one term and the constant. Then you factorize from there. Okay, I hope you understand that, guys. Yeah, Wizard is saying it's like he's speaking an ancient language. I wonder what language is that ancient. And that means you have a comprehension of ancient languages and you are failing to understand this language you are speaking here, which is modern, which is mathematics. You are very interesting, Wizard. Very interesting. You very interesting character. Simplify. 2a squared minus 10a plus 12 over a into a plus 2 minus 3 into a plus 2. So this is the type of simplification where what exactly is happening? You look at your numerator, you apply factorization if possible. You look at your denominator, you apply factorization if possible. You look at your numerator, guys, you have 3 terms, and immediately what jumps out to you? With the 3 terms you have there, first and foremost, you ask yourself the first question: is there a highest common factor? Is there a what? A highest common factor. So 2a squared minus 10a plus 12. Can you guys see a highest common factor in the numerator? If you do, what is it? If you do, what is it? Look at the numerator, look at the denominator, factorize if possible. You guys are 100%. The highest common factor in the numerator is 2. So take it out. Take it out. Take it out. What gets left behind inside the bracket after taking out the 2? Because there's no other highest common factor. There's the sign and the number are 2, but there's no letter that is the highest common factor. What gets left behind for the first term? Yes, the numerator is on top. 2a squared minus 10a plus 12. Okay, over a into a plus 2 minus 3 into a plus 2. What gets left behind? Very good, guys. It's a squared for the first term. Then in the second term, what gets left behind? For the second term, what gets left behind? The second term in the bracket, what gets left behind? User 699 is saying 5. Super not angel is very super there in the comment section. Notando as well. Coleline 14. You guys are amazing. Guban is amazing. Wooden leg, your sign, please. Your sign. Negative 5a, guys. Please, please, please. All right. 2 times what gives you negative 10a? It's negative 5a. Okay. Where did we get the 2 from? We took out a highest common factor, as we always do. For any type of factorization to start, we always ask, is there a highest common factor between these 3 terms? We found that the highest common factor is 2. Then we ask, what is left behind? A squared for the first term. What's left behind for the second term? Negative 5a. What's left behind for the last term? Positive 6. Thank you so much, guys. You guys are amazing. You guys are amazing. Let's go down. Let's go down to the denominator. Let's go down. Let's go down to the denominator. How many terms in the denominator, guys? How many terms in the denominator? How many terms in the denominator? Let's start there. How many terms do you see in the denominator, guys? How many terms? Let's see the magic number. Wooden leg, very good. Gubani, Colin 14, Itumeleng, Super Not Angel, Onji. Guys are amazing. Mohao, Esihle Lamini, you guys are phenomenal. Not 4 or 2. Please don't say 4 or 2. No, 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 no. It's 2. 1, because brackets combine, so that's 1 term. The negative sign separates. 2. Then from there, what is the highest common factor? Remember, Tiniko, thank you so much for the I love you so much as well. You guys have no idea. You understand staying up this long for people that basically you don't even know, some of you, from a bar of soap, and just doing this. This is an act of love. So thank you so much for the love. I really appreciate it. I love you too. We can take out, guys, a highest common factor, sign, number, letter. But if there's no sign, number, letter, we take out a highest common factor b. What is that? Bracket. Do we have a highest common factor? Bracket. If there's no sign, number, letter that you can take out, we can take out the highest common factor. Bracket. Is there a highest common factor? Bracket. Yes, it seems there is. It is a plus 2. It is common. We take it out for the first term. When we take it out for the first term, what is left over on the left? What is left over on the left when we take it out? Okay, a plus 2 is the common bracket. Please, guys, common bracket, not a minus 3. A minus 3 is not common, all right? A plus 2 is common because for the first term, we have a plus 2. For the second term, we have a plus 2. So a plus 2 is common. Then what is left over in the left-hand side? You hide the a plus 2. What's left over on the left? It is a. What's left over on the right? You hide the a plus 2. On the right, you are left with minus 3. That is the factorization of the numerator. And guys, this so far is so good. All right, please, guys, I first write what is the common bracket. Okay, then go back to the numerator. Can we factorize the numerator any further? Definitely we can. Definitely we can. Because what type of expression do we have inside the bracket? We have a 1, 2, 3 quadratic, because there's an exponent 2 for the highest variable. Your exponent is 2. Quadratic trinomial. So we open what? AMBRO AMG brackets. We open 2 brackets. Then what do we have here? a positive constant term. What do we mean when we have a positive constant term? If we have a positive constant term, what does that mean for our brackets? That means we're going to have what? Since we have a positive constant term, what does it mean for our brackets, guys? Check the comments. Multiples. Lusanda, -3 and -3. Two negatives. Thank you so much, guys. Plus means same signs. Remember, guys, when a constant term is positive, it means same signs. Same. You guys are not getting it. Some of you are writing two different signs. Same signs. That's what the positive constant says to us. We are going to have same signs. According to who? According to the sign of the middle term. So that means our signs are going to be negative and negative. That's why I loved Super Not Angel's comment. Two negatives. Notando. That means very good. Then we ask, what are the factors of 3? We multiply those numbers together, we get 6. We add them, we get 5. What are they? You guys are 100% spot on. We have 3 and 2. A squared is formed by A and A. Thank you so much. Some of you guys are just making this live session for me very, very, very beautiful. But some of you guys, you are not listening to me. All right. I don't know if you really want to get this or you don't. A positive constant, guys, means that we are going to have the same signs. But according to who will the same signs be? According to the sign of the middle term. So both are going to be negative. Same. Do you guys know what same means? Same means we are going to be exactly identical. Meaning positive means we're going to have same signs. According to who? The sign of the middle term. So we have a negative and a negative. Please, guys, when we multiply the negative and the negative, that gives us a positive, the 6. When we add the -3 and the -2, we get the -5. Okay, does that make sense? Over. So some of you are just funny, because I can promise you, if right now I would basically come and bring your favorite artist right now, it's at night, you would be jumping up and down here crazy because you are seeing your favorite artist. You guys are just you're doing funky things because it is what it is. Look at this now. Now we can cancel. Exactly. If it was Drizzy and Drake and Kanye West, you guys would be falling over. You would be head over heels. You would be not yawning and sleeping. But now it's maths. It's what you need to pass. You are sleeping and yawning and crying and saying you want to go and you want to sleep. So A minus, exactly, CN Puji. Look at that. You would be crazy here. Crazy. A minus 3. The relationship between 2, A minus 3 and A minus 2 is multiply. This is division. A plus 2 and A minus 3. We can play the cancellation game very easy. Very, very easy. The A minus 3 makes the other A minus 3 at the top to disappear. But this A minus 2 and this A plus 2 can't be cancelled because they are not the same. So what are we left with? 2 into A minus 2 in the numerator. In the denominator, A plus 2. Done. There's nothing else that we can possibly cancel. So we are going to go now and go and check. 2 into A minus 2 over A plus 2. Is there something like that here? Yes, it is C. Okay, it is C. There it is. There it is, guys. C. Yeah, Colin. I see you, what you are saying. You can do it and get good marks, but because I haven't done this in a long time, I understand. That is why, my beautiful friends, I feel like some of you, you need me. You need me at the end of this year. Some of you need me. So some of you need to become part of my early grade 10 preparation for next year. If you guys are interested in something like that, on the 15th of December, I'll be starting an early preparation, sort of like course session if you want. I know it's during December. Some of you don't want anything to do with school and all of that stuff, but you will need that. We will do that. Those who want will become part of that. Just let your parents know that you've met me here. You are having the time of your life with me teaching you maths. You feel like the maths is mathsing for once in your life. Maybe it has never mathsed for some of you. For some of you, it's been mathsing all year round. Okay, I'll tell you of Super Not Angel. Super Not Angel is one of the people that's there in the comment section. It's been commenting like crazy. That one, is a level 7 student, that one, doing the things like nobody's business. And I know that she is a hard worker on her own. But I really appreciated it when she acknowledged that the live lessons have assisted her. Her joining live lessons in the morning and all of that stuff. And it's maintained that sense of consistency for her as far as her mathematics performance. So that makes me happy. But more than anything else, that could be you. And that must be you, because you want to get excellent marks. You don't want mediocre marks. None of you that are here, you are here because you want mediocrity. You want excellence. So let us strive for excellence, but it is to be worked for. It needs consistency, because the thing is, the minute maths is put on the shelf, I promise you, I don't care how good you are, the minute you put maths on the shelf for a very long time, it loses its luster. It loses it loses something. You lose something, because you're not consistent. Hence, some of you, like I said, you will need me to prepare you for grade 10. Like I said, for the classes on the 15th, but like I said, on the 15th of December, please, if you are interested, you can contact me on the side, send me a message. Then also next year, during the whole year, we can maintain that level 7 of 90 and above for the whole year until you finish grade 10, 11, 12. But like I said, you need someone to also consistently follow up with you. I think I'm your person, but you need to figure it out for yourself if you think I am, and then we can move from there. Okay. Maths is a Game is the name of the YouTube channel, Colin, and you can check it out. But more than that help. Please, guys, let's consider this and talk to our parents about it, and let me know privately in the messages in the inbox, and we can take it from there. 35, simplify. Number 35. The common misconception that learners love doing with this question. I cannot begin to tell you the manyalas you can see in a question that is answered by learners when it comes to this. Nice question, by the way. Very nice question. Yes, Smurf. Yes, that's very possible. Okay, guys, look at the numerator. How many terms? You see this thing of asking how many terms in the numerator, then how many terms in the denominator? Can you tell me, guys, how many terms you see in the numerator? I want to see. Colin is saying 2. Itameleng is saying 2. Okay, people are saying 2. CPU is saying 3. Now that's where I just cry. CPU, I cry very hard when you write things like that. Guys, there are 2 terms, guys, in the numerator. 2. 48R is 1 term. All right. The -3 with the bracket, with the exponent, that is 1 term, because brackets combine and this bracket is multiplied with 3R. So therefore, that is 2 terms in the numerator. 2 terms in the numerator. In the denominator, on the other hand, how many terms? As you have said, you see in the denominator, you can say the number of terms very clearly. G-Man has said it. Colin and Itumeleng, Liam, all these people are saying there's 3 terms. Very good. Guys, it seems like this live will end at 12, if I can be honest. But please, when you feel like you're sleepy too much, don't be scared to leave. Okay? No force. Okay? No force. So 48R So terms are separated by a plus and minus sign. Thank you so much, Colleen. 48r and minus 3r. Is it possible to subtract these two? Get the answer and then distribute. Can we do that, guys? Take 48r and minus 3r, but 3r has a commitment. You remember what we said about brackets with the 3r, which is negative. This is actually one term. So can we subtract 48 and 3r is the question. And the answer, guys, is no, we can't. Some of you are going to say, but sir, the 3r and the 48r are like terms. But guys, unfortunately, the negative 3r is the father of this house, this one. You see this house? 3r is the father at the door of this house. The surveillance cameras of this house are making sure that this home, where the mother and the daughters are taken care of. So this here, this 3r cannot be subtracted from this 48r. We can't, because the 3r is already in a committed relationship with p plus 2, the whole thing squared. So it is this 48r and the 3r and the whole thing is an unlike term. We cannot do anything with it. So I hope that's clear for us. So me is going to write 48r alone there. Yes. Look at Smurf. Remember BEDMAS. Brackets, exponent, BE, 3r multiplied to that. We can't subtract when we have not sorted everything else out. So what we are going to do is we are going to take the 3r, it's going to park there for a moment. Then me and you is going to open two brackets of p plus 2. Okay, open what? Open two brackets of p plus 2. Go to the denominator. There are no like terms in the denominator. No like terms at all. So we just leave it like that in the denominator. For now, we have something that we are eventually going to do, but for now, we are just going to leave it like that for now. Let's first sort out this multiplication of the brackets. So that means 48r minus C3r. Okay, then what is p plus 2 into p plus 2? Let's not forget to FOIL. What do I get? P squared plus pq plus pq plus q squared. Okay, over 12r plus 3pr plus 3qr. Now I'm ready to take the negative 3r and distribute it here. Okay, ready to do what? Take the negative 3r and distribute it. But before that, why did I open two brackets here? Because of this guy, brackets. The order in which I operate when I am confronted with multiple signs and operations is I apply BEDMAS. Okay, or some people call it BODMAS, but I refer to it as BEDMAS in grade 9 because B is brackets but E is exponent. So that's why there is a priority to deal with the bracket with its exponent. Immediately I have to open the two brackets because this speaks to B and E. There's a priority on that. So 48r is going to just stand here for a little while. Negative 3r, the dead of the household. Okay, and then we deal with this bracket. We expand, multiply out, and FOIL. Then we have 48r minus. Now, take this 3r and distribute it to all terms. 3r times p squared. That gives me negative 3p squared r. Take this 3r, negative. distributed to positive PQ. That gives me negative PRQ. Take this negative 3R, do the same thing there, another negative PRQ. And then lastly, take this negative 3R distributed to the Q squared. Why we do not add PQ plus PQ? Because we are going to add it anyways when we are dealing with the like terms, when we have the like terms, so it's fine, okay? It's really fine. Then the last term will be negative, 3RQ squared. You could have done it as well, it's fine, 2PQ, it's still going to lead to the same answer, okay? So do it or not do it, all right, as long at the end of the day, we'll be simplifying, okay? Okay, no problem. Emerk44N, I love you so much as well. Appreciate the love, guys. The thing is, you get too much hate in this world. So when people drop their loves there, I love you too. 48R minus 3P squared R minus 3PRQ minus 3PRQ minus 3RQ squared. So what we are going to do, let's go and sort out those specific like terms there. Minus 3PRQ gives us negative 6PRQ minus 3RQ squared all over 12R plus 3PR plus 3QR. Okay, now it's time. It's time to do what? It's time to take out a highest common factor in the numerator and in the denominator. We are ready now, guys, to take out a common factor. So factorization, if possible, guys, we look at the numerator, we look at the denominator, factorize if possible. Is it possible? Yes. So the first type of factorization we always look at is highest common factor factorization. So let me just write these steps here at the top so that we can see what we are doing. Highest common factor, what? Sign, number, letter. Let's look at it in the top. Sign, it's going to be positive. Number, 48, 3, 6, and 3. The highest common factor number is definitely 3. Letter, R. Okay, R is common. Is there any other letter that's common? No. So it's only R. So we have 3R as the highest common factor for there in the numerator. I'm going to open the bracket and I'm now going to check what is left over. 3 times what gives me 48? 3 times what gives me 48? So what you can say is, you can say 48 divided by 3, you will get the number. Okay, 48 divided by 3, you will get the number. What's 48 divided by 3? Okay, some of you are getting 16. Okay, very good. Okay, let's move on. Next number, next one. 3R times what gives us negative 3P squared R. Okay, so the R is out. What's left over? The 3, that's positive, and the R is out. What's left? It's negative 3P squared. No, it's not negative 3P. It's negative P squared. Okay, because 3 and R are out. So we are left with negative P squared. So we can say negative P squared. I hope that's clear for all of us there. Let's move on to the next term. We have 3R that's out. What do we multiply that 3R with to get negative 6? So the number will be negative 2. Negative what? Negative 2 PQ. Negative 2 PQ. Okay. Okay. I hope we are good there. Then we move on to the next one. We took out a negative. We took out a 3R. What are we left with? We are left with the 3 is out, the r is out, so we need a q squared, and it has to be negative q squared all over. Let's go to the denominator. We need the highest common factor here as well. So between 12, that's positive, 3, that's positive, and 3, the highest common factor is also going to be 3. R and R, obviously R. You guys are 100% correct. I opened the bracket. What am I left with now? In the denominator, what am I left with, guys? I'm left with 4 plus, in the denominator, I'm left with, we took out 3R, so I'm left with, for the second term, yes guys, I'm left with positive P. Then lastly, took out 3R, there's a Q there. For the last term, I'm left with, very good, positive Q. Close that bracket. Now, what I can see here is that cancellation is definitely going to be happening with the 3R and the 3R. I don't no longer have an issue there with the 3R and the 3R. It is finally gone, and gone. Who would have thought? But it is finally gone. Okay? Gone with the wind, as it ought to be. The 3 cancels out, the R cancels out, but I'm left with 16. Please take note of this. 16 minus P squared minus 2PQ minus 2 squared. Now I'm going to show you something in this numerator. 16 minus, if I take out the negative sign here for this particular 3 terms, there's something I'm noticing here. 16 is a perfect square. If I take out the negative sign for these 3 terms, I'm left with P squared plus 2PQ plus Q squared. All right. And what this does for me, it exposes me to a difference of what? Of 2 perfect squares. This is what we call, guys, a perfect square trinomial, PST. If you guys never knew, this is what we call a PST, a perfect square trinomial. Do you know what it is about a perfect square trinomial that makes it sweet and unique? For instance, if I give you this x plus 3 the whole thing squared, do you know x plus 3 the whole thing squared? What happens with it is that x plus 3 the whole thing squared, as you saw, we open 2 brackets, right? And then when we multiply out, we get x squared plus 6x plus 9. This is what we call a PST. It's a perfect square trinomial. Okay? The perfect square trinomial. You square the first term, you get x squared. You square the last term, you get the last term. Then you multiply these 2 terms together, you get 3x, and then you multiply that 3x by 2, you get the middle term. That is how a perfect square trinomial is formed. It is formed by a binomial, 2 terms inside the bracket, which are squared. So a perfect square trinomial, when factorized, gives you 2 brackets, as you can see, that are the same. We call this a perfect square trinomial. Okay, I repeat again. X plus 3 the whole thing squared. Remember when we clarified something very important earlier on, and we said you can't square the last term and the first and say the answer here is x squared plus 9. We can't do that. Why? Because this means we are going to open 2 brackets of x plus 3. When we do that and apply FOIL, we get what we call a perfect square trinomial. So guys, look at this once again. I took 16, it is there. Then for these 3 terms, I can see something very quickly, that this here resembles a perfect square trinomial, but for these 3 terms, I need to take out the negative sign so that you can see the perfect square trinomial. What happens when you take out the negative sign? You now have a difference, but here is a perfect square number, here is a perfect square trinomial. All right, so yes, there's a invisible one there because I took out a negative one as a highest common factor for these 3 terms, these 1, 2, 3 terms, because I could see the emerging of a perfect square trinomial. That is why I took out a negative one. Now, you will obviously go ahead and write that with that 4 plus p plus q, which was basically left in the denominator. As you continue, we are going to write 16 minus. Now remember, I said a perfect square trinomial can be factorized to become a binomial, 2 terms inside the bracket with a bracket squared. Okay, binomial with 2 terms inside the bracket and a square. The reverse, all right, when you factorize a trinomial that is a perfect square trinomial, you get 2 brackets that are the same. So a perfect square trinomial, this one here, can actually then be written as, look at this p plus this q with the square on the outside. Haha, hey guys, the p, the q, okay, and then the p plus the q, the whole thing squared. All right, okay. In other words, what I'm saying is that take this and factorize it. Some of you, interestingly enough, p squared plus 2pq plus q squared. What happens, guys, when I factorize this? Okay, we open 2 brackets, don't we? All right. Okay, just confirm for me that you guys understand what I did for these 1, 2, 3 terms. I took out the negative sign. All right, let's just confirm here. This is 16. There's the 16, okay? Minus, all right? Then there's a p squared, there's a 2pq, there's a q squared. So I took out a negative sign here for these 3 terms. When I take out a negative sign for these 3 terms, what gets left behind? A positive p squared, a positive 2pq, and a positive q squared in brackets. Guys, if I took this negative sign back, what's negative times p squared? I get this negative p squared back. Negative times 2pq, I get this negative 2pq. Negative times q squared, I get this negative q squared back. So what I simply did is I could see this is 16, it's a perfect square. But then here, this negative p squared minus 2pq minus q squared, I take out a negative sign. I get p squared plus 2pq plus q squared, and that basically is a perfect square trinomial. 3 terms, it's quadratic in nature, and what I'm saying to you is that you can factorize this particular trinomial. Now, Jacob, you need to tell me, there's a part I don't understand. What part don't you understand here? What part don't you understand here? You don't understand everything. So that means you don't understand. You see that statement to say you don't understand everything. That to me is a very, I don't know, that basically says that you know nothing. Yeah, to say you don't understand everything means you know nothing, right? And I refuse to believe that that is true. You need to specify to me what part. You see, the minute you guys, I do something that you are not really good at, or you're not aware of, you need to not feel so despondent that you begin to dispel or dismiss everything that you've ever learned, and you like say, I know nothing. If you say everything, then it means basically everything I've done up until this point has been senseless and meaningless to you. Okay, that's where I'm crying as well. Okay, I'm crying very hard. So that means as I was doing this, you were lost, you were lost, you were lost, you were lost, you were lost. I got here. Now all of a sudden here you begin to say, I can't hear you. All right, I can't hear you at all. Okay, let's check this guy out. Okay, let's invite someone. It seems like Mr. I am the best is he? Look at this. He leaves as I invite. Okay. All right. You don't understand after I cancel the 3R. Okay. Not all, I heard you. Okay. So basically, guys, here, all right, so you guys understand when I canceled the 3R, you understand that part. The fact that I canceled the 3R because of the fact that obviously those are common. 3R and 3R are common. They are not across an addition or a subtraction sign, so I cancel those two. Where I lose, or I am losing most of you, is where I have 16 minus p squared minus 2pq minus 2 squared. So obviously that was there anyways. Please look at the denominator, guys. What do you see in the denominator? You see 4 plus p plus q. This 4 plus p plus q, okay? We need to then somehow do something in the numerator so that this 4 plus p plus q can also be attended to as far as cancellation and stuff is concerned. Maybe you guys need to just allow me to finish the problem, then I'll go back and explain. Okay, let me so can you guys just allow me to finish the problem, and then maybe when I finish the problem, then maybe we can, you know, entertain you guys. So then from here I have 16, there's the 16, minus p squared minus 2pq minus 2 squared. So what I did, I can see, oh, this is a 1, 2, 3 terms. This is 16. In the denominator, I have 4 plus p plus q. Here in the numerator, there's 16 minus. Take out the negative sign for these 3 terms. Why? So that I can look at this expression in the denominator as having 2 terms. But these 2 terms, remember this now is 1, this is 2 terms. This allows me to set up an expression in the denominator that is a difference, guys, of what? Of 2 perfect squares. Okay, because look at this p squared plus 2pq plus 2 squared. You can actually factorize this trinomial so that it is written as 2 brackets of p plus q. Okay, guys, if I say p plus q into another p plus q, what do I get when I simplify this? What's p times p? That is p squared. What is p times q? That is pq. What is q times p? That is another plus pq. And then what is q times q? That is q squared. So in other words, when simplified, this is p squared plus 2pq plus q squared. This is the product the answer of the product of these two brackets. But remember, this is actually p plus q the whole thing squared. That's what this is. When factorized, p squared plus 2pq plus q squares, it is p plus q the whole thing squared. Okay, I repeat again. P plus q into p plus q, when multiplied, gives you p squared plus 2pq plus q squared. Because I have the eyes to see a perfect square trinomial, here for these three terms, I took out a negative sign. Why? So that I can see a difference of what? Of two perfect squares. 16 is a perfect square. P squared plus 2pq plus q squared is a perfect square trinomial, which can be written as p plus q the whole thing squared. All right. Now, I'm going to apply dots factorization to this. Please check me out. Apply dots factorization to the numerator. Remember, this is all over 4 plus p plus q. Look at me apply dots factorization to the numerator. Now, what is this? It is 16. So what I'm going to do, I'm going to open two big brackets. Two big brackets. The square root of 16. What is the square root of 16? So remember, for difference of two squares, we put a plus and a minus sign. That's the first things. Okay, dots means a difference. When we factorize using a difference of two perfect squares. So what's the square root of 16? It is 4. So we can write 4 on either side of the first term of each bracket. Square root of 16 is 4. It is 4. Then we move to this here. What is the square root of p plus q the whole thing squared? No, guys, really and truly, you know most. The square root of p plus q the whole thing squared should give us what? P plus q. Why do we say p plus q? The reason is that the square and the square root, what do they do? We know most that we would write this as p plus q 2 over 2, which would lead us to a p plus q, because 2 divided by 2 gives us 1. So it means we have p plus q in brackets. We have p plus q in bracket. Yes, the square and the square root, they cancel each other. Or it's like we divide this exponent 2 by the 2, which gives us p plus q. So that means here I'm going to write p plus q, and here I'm going to write p plus q. Guys, do you see this? I've just applied difference of two perfect squares to the numerator. Now I'm going to go back here. Guys, why did Sir look at this expression in the numerator and decide 16, you stand here. 1, 2, 3. Let us take out the negative sign. It is because Sir was trying to make sure that he sets up this expression in such a way that we can see the difference, dots, d, of two perfect squares. 16 is a perfect square. P squared plus 2pq plus q squared is also a perfect square, but we call it a perfect square trinomial. This here can be written as p plus q the whole thing squared. So these are a difference of what? 16 is a perfect square. P plus q the whole thing squared is a perfect square. This is a difference of two squares. Now remember, what did I say? We can factorize, if necessary, the numerator and the denominator. It is only the numerator now that we can what? We can factorize. Okay? We can factorize. So if we look at the numerator, we can factorize the numerator. What is 16? 16 is a perfect square. What is the square root of 16? It's 4. So we write 4 and 4 on either side. Since it's a difference of two squares, we know that the signs inside the bracket will be different. One positive, one negative. Then we take the square root of the second term, which is our perfect square, which is p plus q, the whole thing squared. What is the square root of p plus q, the whole thing squared? It gives us the answer of p plus q. So therefore we write what as our second term in each bracket? We write p plus q and p plus q in brackets. But that is all over what, guys? It's over 4 plus p plus q. Then inside each bracket, we are going to remove this little bracket for each second term. Now check me out as I remove each bracket for each second little term. So I have 4 plus p plus q. Remember that was like this. Then I have 4 minus p plus q over, it's all over what? All over 4 plus p plus q in brackets. Okay. Please guys, look at this now. So in the first bracket, okay, distribute the positive sign. We have 4 plus p plus q for that first bracket. The second one, distribute the negative sign in that smaller nyana bracket. We have 4. What's negative times p? Negative p. What's negative times q? Negative q. All over 4 plus p plus q. Now I'm sure you guys can see that there is some customers that want to be cancelled. Customers that need to be cancelled. This guy can be cancelled with that one, which then equals our final answer, 4 minus p minus q, and that is basically the answer. Okay, now you guys, meaning that when you guys did factorization, you guys never did complex difference of two squares. You guys never did complex difference of two squares. I see why you guys are lost. You guys never did complex difference of two squares. This is a difference, okay? And it's of two perfect squares, okay? But then, look for GEC, the kids are working things out so that they can actually get awarded 1 mark for selecting the correct answer. So that's basically GEC. Don't ask me why they do it like that. I am not the person who came up with GEC. I am simply the teacher who is in the system, who is trying to help those who are preparing for GEC at the moment. Okay, so guys, we need to be familiar with this type of factorizing for difference of two squares. Okay, this is 4 minus x plus y, the whole thing squared. You look at this, this is a perfect square. You look at that, this is also a perfect square. So that means you can apply factorization by opening two brackets for a difference of two squares. And for everything, you know most that the first bracket will plus, the second bracket will be minus. Then you ask the square root of 4, what is it? It is 2. Okay, then the square root of x plus y, the whole thing squared. That means in brackets you can write x plus y, and here you can also write x plus y. All right, and then from there you make sure you simplify the bracket. Okay, you simplify each bracket so that the final answer, you distribute this positive sign, you get x plus y. Okay, and then lastly you distribute this negative sign so that you get 2 minus x minus y, and that basically is the factorized form of the answer, 4 minus x plus y. the whole thing squared. I thought you guys were saying, please do the difficult ones. Now, all of a sudden, I'm there in the place where we are doing difficult ones, and you guys are crying in the comment section. Okay, I didn't know that there are people who will be writing GEC Maths Paper 2 as well. In some provinces, they're writing Maths Paper 2 as well for GEC. It's very interesting. Very interesting. Okay. G-Man, if you have 4 plus x plus y, the whole thing squared, the sum of 2 squares, we cannot factorize this. Okay. It's only a difference of 2 squares that can be factorized. So this one, you just leave it like that because we can't factorize. If they say to you, factorize this, then the answer is exactly this, what you see. The addition of 2 squares, we don't factorize. But the addition of 2 squares, we don't factorize. But the difference of 2 squares, you factorize by opening 2 brackets. You take the square root of the first term, you write the first term in each bracket. You take the square root of the last term, you write the last term in each bracket. And then if it's a binomial like this, a binomial term inside the bracket, you distribute the sign so that eventually you can get the simplified form in each bracket as your answer. Okay. Yeah. Okay. Remember I said 12, guys. Okay. I said 12 marks. So GEC learners, if this was a similar question in your question paper, then it means you guys need to be very much also alert and awake to certain questions like this. Perfect square trinomials. You see this term, perfect square trinomial. Supernode Angel saying 12 marks. If this was a normal question in a question paper, I'm sure 12 marks would definitely be in the cards, right? Okay, and do you see that this answer? It is C. It is C, guys. That's the answer. C is the answer. Simplifying this basically means you get an answer and C is your answer. There's no other answer but C. Okay. Yeah, ne? That was quite a meal of a question. Okay. But why do we all do all that for 1 mark? It's because you are loved. Some things in life are very difficult and they need you to basically get stuck in, pull in some grit, and just do it and do it and do it without complaining. Okay, so minus 2 is equal to minus 4m. What is the value of m? Guys, this one, it should be straightforward. This one, you will spend 10 seconds answering this question. You'll get the answer just like that. I see D. Lusanda is saying it's D. This is for grade 9. Okay, Lusanda is saying it's D. Does anyone else agree? What is the value of m? If minus 2 is equal to negative 4m, Nels is saying it's D. G-Man is saying it's B. What the? G-Man is saying it's B. Long lasting is also saying it's A. Some are saying it's B and A. What? Guys, I don't understand 36. Chomi. Hi, Chomi. Yo-ho-ho. Chomi. Yo-ho-ho. What is this, Chomi? Chomi. Hi, Chomi. Hi, Chomi. Hi guys, guys. All right, guys, they are saying minus 2 is equal to negative 4m, and they are asking what is the value of m. This is the same thing as saying solve for m. Okay, so minus 2 is equal to negative 4m. Remember, guys, that negative 4m is the same thing. If you say negative 2 is equal to negative 4m, it's the same thing as saying negative 4m. This negative 4m is still negative 4m. This negative 2 is still negative 2. All right. So let's just solve this. And negative 4, what is the relationship between negative 4 and m? It is multiplied. So how do we get rid of the negative 4 that's multiplied to m? We divide by negative 4. But remember, what we do on the left, we do on the right as well, guys. We do on the left. We divide. This is what we mean by multiplicative inverse. You are applying the multiplicative inverse here. What is the goal of applying the multiplicative inverse? It's to get 1 that is positive so that you have 1m in other words. Remember that 1, it's invisible. That's why it's written as m at the end of the day. Okay, so we apply, this is negative 4, it's multiplied to m. How do you get rid of -4 that is multiplied to m? You divide by -4. You divide by the same number. You divide by it. So it's like saying if you have -4, you multiply by -1/4. Does that make sense, guys? Because this dividing by -4, it's like we are multiplying by -1/4. That gives us 1. Okay, but since there's an m, we say 1m. So m is equal to, but what you do on the left, you must do where? On the right. What is -2 divided by -4? Hi guys, -2 divided by -4. It's positive half, not 2. Some of you are saying it's 2. Some of you are saying it's -half. Hi guys, hi guys, hi guys. M is equal to half. That's positive. Hey boo. Hey mandora. Okay, so it's D. The answer has to be D. Please guys, don't lose marks unnecessarily. You see now, these people that come here and choose A and B, you guys are just saying goodbye marks. We don't want you. Don't cry, say, I am crying. You guys are doing funny things in the life. You're getting answers that you shouldn't be getting. What do you expect from me? Well, you guys are the ones that are actually making me emotional. What do you want from me? Okay, let's go here. 37. 37. A over 7 is equal to -2. Guys, please, what do we want? The value of A. All right, the value of what? The value of A. So who is the problem at the moment that is standing in the way of A being? We want A to be isolated. Here we wanted M to be alone. All right, so we divided by the -4. Here we still want A to be alone. But what is the problem? There is 7 that is in the denominator that is divided. So how do we get rid of the 7 that is divided? We multiply by 7, not in the denominator, but in the numerator. So what we do on the left, we must do where? On the right, guys. We multiply by 7 over 1. Because here, A is divided by 7. So it's like we have 1 over 7 here. What do we multiply this 1 over 7 by to get rid so we can get 1? We multiply by 7 over 1. We are applying the multiplicative inverse. This is what we mean by applying the multiplicative inverse. We times by 7 over 1. This 7 is in the numerator. What we multiply by is the 7. This 7 is in the denominator. The one we multiply by must be 7 in the numerator, because this one is in the denominator. The 7 and the 7, they cancel. We are left with 1 and 1. A is equal to, what you do on the left, you times by 7, you do to the right. So that means you get -14. Can we just take the 7 times -2? Yes. Some people say cross multiply. That's also fine. Okay. It's the same logical understanding. But the concept behind it is multiplying by the multiplicative inverse. Okay. So that we get the answer. So B, guys, is the answer. You guys said funny answers before. B is the answer, okay? Please, man, don't do these funny things here. Do funny answers, okay? B is the answer. Let's move on to 38. Solve. X minus 4, the whole thing squared, is equal to 0. A is x is equal to 4. B is x is equal to -4. C is x is equal to 2 or x is equal to -2. Or D is x is equal to 0 or x is equal to 4. Which one is it? Vibing with the Vutari is saying A. Esihle is saying C. Are you kidding me? B from Mr. Who's this? This was the guy that was comparing me. Brocco, Mr. Wasted was the one that was comparing me with his goat, Mr. Kevin. That's in science. Please, guys, don't compare me with other people. All right? There's value in people. You guys don't understand that in life, everybody and everyone holds value and significance. Everyone is iconic in their own way. You know, when people decide to compare one other person with another, that's where you guys actually take away the value of the person that is in front of you. Everyone is iconic in their own individualized and unique way. That's important. Don't do this funny stuff here of like comparing and comparing and comparing. Pep talk, yes. You need pep talk. Your generation of yours needs pep talk all the way. Solve for x minus 4 the whole thing squared. Guys, the answer is A. Okay, the answer can only be A. How? We have x minus 4 the whole thing squared. It's equal to 0. All right. So we know this is x minus 4 into another x minus 4, which is equal to 0. This is what we call factor. We have the factors here. So we take x minus 4 equal to 0, or we say x minus 4 is equal to 0. Now from both situations, here we are applying what I call the zero factor law. Okay, once we have the factors in brackets, we apply what we call the zero factor law. You take the 0, you equate it with x minus 4. You take the other x minus 4, you equate it to 0. Then you solve the linear equation. You take the negative 4 over, you get x is equal to 4, or x is equal to 4. But you see, guys, this is one answer. In essence, the answer is what? The answer is 4. X is equal to 4. If you take this 4 and you put it in here, what's 4 minus 4? It's 0. What's 0 squared? It gives you that answer. So really and truly, the answer is only 4. It cannot be anything else. So that's why we select A. A, x is equal to 4. There's no other answer that satisfies that equation. Let's come here. What are the values of x here? X minus 3 into 1 minus x is equal to 0. X minus 3 into 1 minus x is equal to 0. So I'm seeing a lot of C's in the comment section. My girls is saying B. Just one person deviates from the answers that have been said. Jabulo says C, Melanie says C, Lusanda says C. So can we then be in agreement that indeed, since this is a 0, your question you want to ask yourself, what x value can I substitute in the place of x, which will basically make this bracket 0? What minus 3 will give me 0? It's 3. So x is 3. So I'm looking at this A and C and I'm like, okay, x is equal to 3 for both of these. Let's come here. What x value can I substitute here that will give me the value of x? That is if x is equal to 1. All right, because 1 minus 1 gives me 0. So if x is equal to 1, then I can say the answer that is appropriate is C. Not any other answer, but who? But C. Okay, I hope that makes sense, guys. The answer is C. C, C, C. Or when you solve it, x minus 3 into 1 minus x is equal to 0. Once again, we are at that factor stage. So we apply the zero factor law. We take each bracket and we simply do what? We equate it to 0. The zero factor law. Take this bracket, equate to 0. Take this bracket, equate it to 0. Then we solve each individual expression. So x is equal to, take the negative 3 over, x is equal to 3, or 1 minus x. 1 minus x is equal to 0. Negative x, you take the 1, is equal to negative 1. Take this positive 1, take it over, it becomes negative 1. Then you divide both sides by negative 1. So x is equal to positive 1. So x is equal to 3, or x is equal to 1. I can see those answers. They are there. If I had been told to actually solve and required to show the steps, this is what basically I would get as my answers. So what I had done by substituting the values was getting the answers by inspection. But when I solve it, I move away from inspection and I solve, showing step by step how to get to the solutions. I hope that makes sense, guys. I hope it makes perfect sense that we factorize. This is in the factor stage. we apply the zero factor law. So we take each individual bracket and equate it to 0. Then we solve for x. Okay, you get x is equal to 3, x is equal to 1. Your teacher is sending you this paper because probably they are feeling the pressure to prepare you because they know you are writing the day after tomorrow. That's why. Let's look at this question where Marius is buying a cell phone. Marius buys cell phones for X rand. Okay. Marius buys cell phones for X rands. Each and sells them to make a profit. He determines his selling price, which is Y rands, for each phone by doubling the price he paid and then subtracting 3 rands. Which equation represents the scenario? So let's look at this again. Marius buys cell phones for how? For X rands. Okay, X rands. Each. You can imagine, X rands each. We don't know the exact amount. That's why we use a variable to stand in the place of the amount that we don't know. And sells them to make a what? A profit. So he sells to make a profit. He determines his selling price, Y rands, for each phone. By what? By doubling the price. Determines his selling price for each phone by what? By doubling. The word double means 2 times, right? Doubling the price he what? He paid. And then subtracting 3 rands. Okay? Doubling the price he paid. What is the price that he paid? It's the X rands. All right? So that's like saying 2x or 2 times x. Then they are saying doubling the price he paid and then subtracting what? 3 rands. Subtracting 3 rands. He doubles the price he paid. All right? 2x. And then it says he subtracts 3 rands. Which equation represents the scenario? Okay. Y is equal to x minus 3, the whole thing squared? No. Y is equal to 2 into x minus 3? Nope. Y is equal to x squared minus 3? Nope. And y is equal to 2x minus 3? Yes. 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 So yes, we are here at D. This is the description of the answer that we are interpreting when we look at these statements. Marius buys cell phones for X rands each and sells them. So he buys these cell phones at X rands each and then he sells them to make a profit. So he sold them. He determines his what? His selling price. Okay? Y rands for each phone. Y rands for each phone by what? Doubling what? The price. He doubles the price. Doubles the price he paid. All right? So that's 2 times x. That's what doubling the price, doubling the price he paid means. Then subtracting 3 rands. So means he subtracts 3 rands, which is minus 3. So then they are asking which equation represents the scenario. It is not A, it's not B, it's not C, but it is definitely going to be what? D. Okay? That is the price that he paid. Guys, you need to get familiar with algebraic language Why? Because algebraic language, guys, will destroy you if you don't understand it. Okay, so these are things that you need to make sure that you understand. Terminology, various ways that basic operations can be expressed in words. Okay, sum of means plus, more than means plus, add, exceeds, these are all words in English that means add. Less than, decrease, difference means subtraction. These are all words that mean subtraction. Products, multiply, times, these are terms in words in English that mean multiply. Divide and quotient definitely mean division. Then there's squared, all right? There's square root, there is cubed, and there is cube root. Okay, right? And then there's twice, double, three times, thrice. These all mean, twice means two times, double means two times, thrice means three times, and so it goes. So you guys need to be familiar with the language that we then use in English so that you can be able to write down algebraic expressions. If you don't know the language, then there are certain questions that will go beyond your personal understanding. So there we go. For instance, if you look at the unknown numbers and variables, we can write algebraic sentences. We can say things in English and then write an algebraic sentence. That is something you guys need to be familiar with. Something you should have learned in grade 8, something you should have reiterated in grade 9, and it's something you should now know for yourself. Okay, so yes, guys, please, the GOAT of all time is definitely will always be Kevin, Maths and Science. Me, I am not comparing myself to him at all. Like I said, he has and he is amazing. I love him myself. So you guys definitely go and check out if you want to learn these things, more basically and simply. Go please check him out, because me, I absolutely love and adore the man and what he is doing for the mathematics in the nation. He's doing phenomenal stuff, really and truly. He's doing some amazing stuff. So please go and check. I think that was 40. I think let's hold it right there for today, because what then 41 and 42 goes into a little bit different content. So I think, well, actually not really, but I think I'll hold it at question number 40. Thank you so much, guys. It was really good to have you guys come over here. The name again, you mean Kevin, Maths and Science. You can go check out Kevin, Maths and Science. Got a beautiful YouTube channel. Really invested time, the guy. Animations are amazing. Yeah, he really does the most and the best. And thank you so much for joining in. I'll see you guys tomorrow morning. I'll be starting off there at question 41. I'll try and upload this video as soon as I possibly can. So I'll see you guys at 5 a.m. tomorrow morning, and then also maybe later on in the afternoon. It's just that, like I said, it gets a bit busy during the day. Even though I would love to go live at 1 p.m., becomes a bit difficult with the network where I am located during the course of the day at around 1-ish. So the best time for me becomes the one that I have in the evening. But yeah, I'll see, guys. But if I don't go live, please, guys, do the last bit of preparation that's there. And yeah, I trust you guys will do what needs to be done. But thank you for joining in. Look at you, 270 of you still, 3 minutes past 12. I think you guys deserve an absolute round of applause. I think, I definitely commend the I commend you guys for being here. You guys definitely So cheers, guys. I'll see you when I see you. And yeah, cheerio, tutors. Let me go forward. Cheers.